Okay, here we are again. Oops, can't answer that. We've given a little starter question here. Remember what we did in Matrices lesson 3. It was all about solving simultaneous equations. So could you solve these? We're given a unique solution for these matrices. Use the matrices to solve these equations. So you have to set them up one under each other, then get a matrix A. Find that matrix A has a determinant which isn't 0, and then you can work out the inverse matrix and to get what we call, if we wrote down in the form, originally it'll be in the form AX equals B, and then you want to find X, so it'll end up being A inverse B, like we did last time. And you can do A inverse B on your calculator and you will get some answer, maybe that one. We shall see. Have a go, pause the video and then see how, unpause, and we'll see how you've got on. Okay, unpaused. Here come the answers. So the determinant was -10, so it had an inverse. Oh, they've found all the inverse, but there you probably jump down to here if you're using your calculator. Put it in the machine, gives you this, so the answers are -1, -2, 5. So that's what we were calling last lesson, case 1. That's what we did in matrices 3. Okay, matrices 4. The difference is here that we're not going to have a determinant of a number. We're going to have a determinant of 0. And therefore the planes aren't going to meet in one unique point. Something else is going to happen, and it could be various things. So let's find out. So matrices 4, hope you've got your handout ready to fill in the blanks. Or you can make your own notes. It says we've got to understand that represents a plane. If you remember, we mentioned it last time. That's just the Cartesian equation of a plane where it's come from Rn equals An. Oops, doing N. The ends are the perpendicular vectors. A is just a point on the plane, and R is x, y, z. So that's what gives that. We've got to know that if equations are said to be consistent, they're led to true statements, such as x is 4, or 0 equals 0, or 2 equals 2. We've got to know that if equations come out giving us nonsense, like 8 is 0, then they are called inconsistent. And that's a false statement. Hopefully you know that. We're going to be using the calculator, so make sure your mate is here. So you've got him ready. And we've got to also be able to distinguish the geometric representation of our 3 planes. So writing. So the geometric arrangements of 3 planes. As for 2 equations, the matrix method fails if the inverse of a matrix does not exist. That is, if the determinant is, get pen ready, 0. If, therefore, the inverse will not exist. The matrix method will lead to a, if the inverse does exist, if I read it correctly, if the inverse does exist, the matrix will lead to a unique solution, like in last lesson. However, if it's 0, we're not going to get an inverse. So otherwise, there may be no solution or infinitely number of solutions. Infinitely. Infinitely number, an infinite, it's just be an infinite, wouldn't it? Or an infinite spelling's awful. Infinite number of solutions. Assuming none of the planes are the same, the 5 possibilities could happen. So it could be that our 3 planes are parallel. Won't draw them because the pictures of them are coming up in a minute. It could be that 2 of our planes are parallel and the 3rd is not. Or it could be a triangular prism. It's a triangle. There could be, case 2, there could be infinite number of solutions, and this calls a sheaf of planes. All the planes, 3 planes meet in a line. You'll see pictures in a minute. Or it could be last lesson we had a unique point where the planes all intersect at a single point. And we saw pictures of that last lesson. Our first job should be to look to see if any of the planes are parallel. That is, the coefficients of x, y and z will be the same or a multiple of each other. However, the constant term does not need to be the same. So don't worry about looking at those. If this is not the case though, if they're not parallel, then infinite solutions of the planes, if there's an infinite many solutions of the plane, it must form we call a sheaf of planes. And if there are no solutions to the planes, it must form a triangular prism. That means that they don't all meet. Two planes will meet, the other 2 planes will meet, but they're not all meet at a common point. So there'll be no solutions, and it forms a triangular prism. Okay. So here's a little flow chart you might find useful to help you when you're sorting out. Really, you get 3 planes, 3 unknowns from some sort of weird question. I would say check here. Check if any parallel. Or you could do that at a stage there also, because you could do it there or there. Then look for the determinant. Is the determinant 0? Well, if it's yes, bingo, we're in. Yes, well, they're going to meet at a single point. Oh, sorry, no, whoa. If the determinant is 0 and it's no, that's what I meant to say. If you've got a value, then it's bingo. The determinants will be a solution because it'll have an inverse. It'll be call the matrix non-singular. They'll end up with a unique solution. That's case 1, like we saw last lesson. They'll all meet at a unique point. If the determinant is 0, then we call it a singular matrix. You heard that from Cartesian last year. And then we're unsure whether it's any of the other things. So what we need to check first is the equations we've got, are they consistent or not? So do they have solutions or do they not? Does your calculator say no solution? If it says no solution, then it's going to end up being a triangular prism. If your calculator says there are infinitely many solutions, then it's case 2, and it's actually going to be what we call a sheaf. So I should say you could check for parallel. You don't really need to check for it there. Let's scribble that off. In fact, I'll rub it off, pretend I never did it. So where we should really start checking for parallel business is, well, choice is yours again. So if the determinant is 0, then there's where I'd probably check to see if they're parallel. Righty-ho. So this first example is example 2. It's a single, all the planes are meeting in a single line. You can see it in this picture here. I'm going to prove this in a minute, but that's called your sheaf. So here are my 3 equations of planes. So I'll set them up as a matrix. We need a matrix AX equals B. So that's my AX equals B. Lovely. Right, determinant of this, pop it in your machine. If you can get that matrix popped in your machine, if you remember how. So that's run mode. You'll have to press F3, 3by3, pop it in. Exit, exit, then you have to press Option, F2, F3, determinant, and then you have to put mat A. So det mat A, and it tells you it is 0. So on your calculator, you need to say det mat A, or it won't work. So if I determinant, recall, this means matrix A cannot have an inverse. If you like, you can call it a singular matrix. So here, a unique solution does not exist. Right, now we're going to work out, are they parallel first? You should be just looking by observation. Are any of those lines on the matrix A parallel? Well, they're not, are they? No, they're not. So it's now going to be, we cut it down then, they're not parallel, so we're going to either be a sheaf or a triangular prism. If our calculator in a minute tells us that there are infinitely many solutions, then it will be a sheaf, and if there are no solutions, it's a triangular prism. But we know it's going to be a sheaf, so anyway. So let us try to solve this, first of all, without the machine to start with. Let us try to solve this system of equations algebraically by eliminating one of the letters. We're going to try by eliminating the letter y. So you can look back at the equations if you don't like the matrix here. We're going to try and eliminate y from 1 and 2. And the same, sorry, let's read that. Letters A from 1 and 2. Then the same from 1 and 3. What do I mean by that? Well, what I mean by that's a bit daft. If we look at matrix 1, look at lines 1 plus 2, you'll see I'll get rid of the y value. So if I use like line 1 plus 2, but it's referring back to those equations. If you can look back at the last sheet, if I look back at the last sheet, it won't let me. So equations 1 plus equation 2, what you get then is 3x, you can see from just adding these basically, and minus 1z. And you'll get the constant working out as 5. If I eliminate the y using the bottom two here, so what I'd have to do there is equation 3 plus 3 lots of equation 2. Then what we do, we've eliminated the y, we just get 15x minus 5z equals 25. Now what I'm going to do is going to use my calculator to solve that. So you want to go on your machine now to menu, equations mode. We're solving simultaneous equations. We've got two unknowns, forget the y, and pop them in. 3 minus 1, 5. So you're in simultaneous equations. 15 minus 5, 25. And then press solve. And oh, it says no solution. No solution. Does it? No, it doesn't say no solution. You put the wrong thing in. But that was all right. If you put 25 in there, what do we get? That's rubbish. It says infinitely many solutions. My calculator, if you look, if you get yours to say the same thing. Infinite many solutions, and it puts some things down the bottom. So, no, it didn't say that. It says, calculator says, I'll spell it from the calculator. Infinitely many solutions. If you weren't comfortable with using your calculator, then what you could do is you could try and solve those two simultaneous equations by hand, and I'll show you what happens. I think. Here we are. You can alternately try and solve those two by hand. So if we're trying to solve those two equations by hand, I'll write them down again because we can't see them, can we? Call them A and B. Now, if we do try and get rid of, we do B, take, so this one take 5 of those. Let's see what happens. Then we get that, take 5 of those, so those are gone. That, take 5 of those, oh, and those are gone. That, take 5, oh, those are gone. So you get 0 plus 0. So you get, in fact, you get 0 equals 0. And that's what we call a consistent. Consistent comment. They call it here consistent. But it said, are these consistent? Yes, well, they are consistent. So we call that consistent. So if it says infinitely many solutions on your calculator, so the calculator says infinitely many solutions, that means the equations are consistent. So I'll put equations consistent. Means infinitely many solutions, and if it's infinitely many solutions, this system is called consistent and it leads to an equation which is true. And this case, the 3 planes will form a sheaf. If you look back at the picture, they all meet, the 3 planes all meet in one line. So you've got, I won't draw them because I'm awful at drawing. The planes meet in one line. I've got many pictures coming up later that you can save or copy. Right, next one, next case. But it's not going to be a sheaf this time. It could be what we call a triangular prism. There he is, that lovely picture there. So we've got 3 equations again, pretty similar. If you remember last question we just done. The third equation says it equals 80, not like it. What do you equal for? It equals 10 or something else. No, it equals 19, isn't it? Anyway, so we've got this new thing here. If we write out the determinant of A, it's going to be the same as the determinant of A was before, I think. No different. Or is it different? Let's check. Is it different or not different? I believe it's the same. So it's in matrix A. You can check it on your calculator if you want to put it in, reprint it in. So mat A equals whatever. So det of mat A, should write that, will equal 0. Same as in question 2. And you can check that again if you don't like the idea of it. And these 3 planes form a prism, triangular prism, or just prism. You can see it's a prism, triangular. There's our equations again. Right, you could write them out as ax equals b, but we're not going to bother. We know there's going to be no inverse, so we go, no, it's not going to be not a unique solution. We look to see if there's any parallel. Same matrix as before, so obviously they're not going to be parallel. So it's now going to be a sheaf or a triangular prism. We've just done sheaf, so it's going to be triangular prism, isn't it? But how would we prove it? Well, we try to eliminate again, eliminating the y values. So very similar to last time, we're going to do 1 plus 2, equation 1 plus equation 2. And when we do that, we get, so we've got equation 1 plus equation 2, we get 3x minus z equals 5 again. And if we do the same with the other one, what was it? Now we're doing equation 3 plus 3 lots of equation 2. And what we end up this time, we're slightly different on the constant. 15x minus 5z equals 86. Right. Solve those on the calculator. So SE on calculator. And if you put those in your equations mode, two unknowns. And what it will say is, just change that 25 into an 86 if you're doing it last time, no solution. So if I just fix it there, check you were doing that. And then that, and it goes, no solution. Solve on calculator, says, it doesn't speak. If you start speaking to you, better call 111. But it shows you, it doesn't say, it just shows you, but never mind, shows you no solution. And that in what we call maths, it's going to be inconsistent. If you want to see what I mean by inconsistent, you'd have to solve them by hand. So alternatively, solving these by hand, we would do, if we called these A and B, like last time, what did we do? We did B take 3 A's, or not take 5 A's, to get rid of the x's. So you get 0 plus 0 equals, oh, this time you get something like 51. So this leads us to a nonsense statement. So we call that inconsistent. Rubbish. So this system is called inconsistent. False. As to equation which is false, probably. Yeah, false. And in this case, the 3 planes will form what we call the triangular prism. Okay, the picture was on the first bit of this thing. Right, let's go for when the planes are parallel. So you get your 3 planes, there they are, different this time, so your A matrix is going to be different. Put the new A matrix in, if you like. So run mode, F3, 3B3, 2, minus 1, 2, ignore the B matrix, 2, minus 1, 2, oh, it's the same line, 4, minus 2, 4, and that's a multiple of the others, isn't it? So that's pretty obvious. Now if you go and press exit, exit, then option, and then F2 for matrix again, and do determinant of mat A. What's my mat A? And you should get 0. So here, det of mat A equals 0. Check it on your calculator, we've just done that. And these 3 planes are what we call parallel. Oops, let's get my pen on. So there we go. And you can see why they're parallel, because actually line 1 equals line 2. Don't ignore the constants, but for matrix business, row 1 equals row 2. Woo. And row 3 is just 2 lots of row 1, isn't it? And row 3 you could say was 2 lots of row 2, because they were the same thing. These would lead to inconsistency. If you put them all in your equations, it would come up with inconsistent. So the coefficients of each equation are all multiples of each other, but not the constants. It means not these 8, 2, and ignoring those. Those don't have to be parallel of each other. So all 3 planes are parallel. No real investigation needed. You know it's going to be 3 planes, one on top of each other, sort of thing. Never going to cross. The other option where you get two planes which are parallel and the third one isn't, equations will still outcome inconsistent. Here you go. So if you put in matrix A as 2 minus 1, 2, 5 minus 3, 2, 4 minus 2, 4, if you like. So we go back in here, exit, exit, drop into that matrix 3 again. So it's only the middle line we're changing, isn't it? 5 minus 3, 2. Exit, exit. You can still test for yourself. Options, F2, F3, and then mat A. Determinant mat A, and it'll give you 0. I don't know if you can see that, that's what we're doing. We've changed mat A to this new matrix, so determinant equals 0. Check it on your calculator, so we know that it's not going to be a unique solution. So you're then thinking, is it now going to be consistent or inconsistent? In other words, is your calculator going to say there are infinitely many solutions and then it'd be a sheaf, or is it going to say there's no solutions and then we've got to decide if they're parallel or if it's a triangular prism? And obviously, as we've seen the picture, we know what it's going to be, but let's carry on. We spelled parallel wrong there, but never mind. Maths teacher, not English. So what we'll do to look at these, we see that row 3 is in fact, because we've seen it before, two lots of row 1. So those two planes are parallel. Coefficients of the two equations are multiples of each other, but not the constant. Doesn't matter about the constant. In other words, that 3 and the 20 are not really doing anything. So we wouldn't go really any further as soon as we found something's parallel. So we say, so 2 of the 3 planes are parallel. Oh, got to go back. So, that picture was 2. You don't need to. 2 were parallel and 1 wasn't. So the 3 planes were never all meeting. And that's why they're called inconsistent. So here's a summary with pictures. You've got a slightly bigger thing on your sheet, thankfully. And you could print this off even bigger if you wanted. So basically, if there is a unique solution, the planes will meet at a single point. The matrix will have a non-zero determinant and they'll meet at a single point like that picture there. Right, case 2, we get a sensible thing when we try and solve it, so they'll be consistent. But the planes, they won't be a singular matrix because you'll have a determinant of 0. But you'll find out that when you eliminate y, the other two equations will give something that makes sense when you try and solve them. This means that the planes meet in a line, forming a sheaf. And when you eliminate a variable twice and try to solve the remaining solvers, you'll get something that makes sense. 0 plus 0 equals 0. So in other words, they're consistent from that. That's what you get. If they end up inconsistent, because when you try and solve your simultaneous equations, you get 0 equals 7 or something. Then, as long as they're not parallel, you check that 2 lines in the 2 rows in the matrix aren't the same or multiples of each other, then it will form a prism or a triangular prism. And then the other options were if all the 3 planes were parallel, the thing would still give what we call an inconsistent if you tried to solve the equations. You'd be a bit mad if you bothered. Just stop if you can see one's a multiple of each other. And the similar thing, if 2 of them are just 2 rows of multiples of each other, we say 2 of the 3 planes are parallel. So though all 3 will never meet in the same place or anywhere, so you don't need to go any further. The picture would look a bit like that. So here are, you've got them on your sheets, you can see, yes. Here are 6 equations, 6 questions for you to try and see what you get, what shape you're going to get for each 6. So you need to pause the video for a long time, or pause it, do one and come back, do another, etc. However you want to do it. But pause now, and then I'm going to unpause, and we're going to look at the answers. So pause now, please. Beep. Oh, here she is. So hopefully now you've unpaused and you are excitable to see the answers or so on. So here we go. So there's questions A and B. Determinant with 0. Ununique solution. Oh, sorry, unique solution. It wasn't 0. Rubbish. They haven't shown much working out, have they? So determinant was a number, and that's where they met a unique solution. The second question, determinant was 0. They worked out inconsistent when you tried to solve them. And 3 planes formed A, and I'm hiding it out. But if they were inconsistent, it could have been they were parallel. So you look to see if they were parallel, and I don't think they were parallel. So that must be a triangular prism. Let's just check on for you. Yeah, a triangular prism. So I'm hiding that. C. Determinant worked out to be 0. Again, inconsistent. Were any parallel? Yeah, looking at lines 2 and 3, they look pretty parallel to me. Yeah. So basically that one was 2 of the planes were parallel. D. The determinant wasn't 0, so that we meet it with a unique solution. So you had to do your A inverse B to find your answers on your calculator, and they came out at those. E and F, here we go. E, determinant worked out to be 0. It says dependent, that must mean they're consistent. So your calculator said infinitely many solutions, which led to being a sheaf. Meeting a line, so there was a sheaf. I'll write sheaf there. I don't like dependent because that's not what the exam board used. So it would say consistent. He ended up with a statement like 0 equals 0 or something like that. So they meet in a line, so that was a sheaf. This one, determinant was 0. Ooh, what's going on? If you look, equation 2 is a multiple of equation 1, and equation 3 is a multiple of equation 1. So they're all 3 parallel. All 3 of the planes were parallel, so you didn't need to go any further. Right, hope you enjoyed those. There is an exam question here for you to have a go at. So you want to have a pause of this video, this slide, and have a whirl at this. It stops you using the calculator a bit, doesn't it? It says find, in terms of A, the determinant of A. Personally, I wouldn't do any, you could do row and what's it operations, but we know you've not particularly enjoyed those. So I just expand it out using one of the lines as it is. It's not too tricky, isn't that one? And then off you go with the others. It says, gives you 3 equations for each of the following values of A. Determine whether the equations are consistent or inconsistent. If the equations are consistent, determine whether or not they're not. Whether or not the equations are no, I'm reading the bottom bit. If the equations are consistent, determine whether or not there is a unique solution. So that's not too strenuous because you have to put the values in for A, and then it's easier to do, isn't it? So you can use your calculator. Okay, pause the video, off you go. 9 marks there. Windy today. Spin the globe. Why can we not go on holiday? Right, okay, hopefully you've unpaused. And here come the answers. Oh, right, so we're on the answers. Answer to part A, the determinant. If you work that one out, I've expanded it from the top row. You get a squared minus a. If you expand it with any other row, you get the same thing. So part B, when a was 0, you see the determinant will be 0, so there's not going to be a unique solution. Put 0 into your equation, you end up with those three things. Hopefully you can see equations 1 and 2 are parallel of each other because you've just got z, nothing else. So 1 and 2 planes are parallel. So 2 of the 3 planes are parallel, full stop. So they're inconsistent as well if you tried to solve them. B, when a equals 1, you get 3 different looking equations. And using the determinant, a squared minus a1, take 1, still 0, so no unique solution. Try and solve the 3 equations, eliminate one of the letters. I've eliminated x. If you solve them on your calculator, it will tell you that there are many solutions. So we say, or we solve them like this, you get 0 equals 0, so they're consistent. They're consistent and it will form a sheaf. And the last thing, when a was 2, then 2 squared minus 2 is not 0, in fact it's 2. So there's going to be a unique solution. So you can then do your x equals a inverse b on your calculator when you've put a and b in, and it leads you to these solutions 0, 0, 1. Actually 0, 0, 1. So I hope you enjoyed that. A lot to take in. There is here a summary of those things. You can print that out yourself. I'll send it as your single sheet so you can have summary of what, if it's going to be a parallels. So if they're inconsistent, it's going to be all 3 are parallel, 2 are parallel, or a triangle prism. If they're consistent, you get something like 0 equals 0. You're going to get the sheaf. And these are all, so here we've all got determinant equals 0, determinant equals 0, and on the top one is the determinant doesn't equal 0, and they all meet a single unique point. And you can find it by doing the x equals a inverse b. So lots of fun there to have in exercise 6, probably D. I hope you enjoy yourself. Right, goodbye from me for now, and I shall see you in the next one.